Have you ever wondered how the placenta, the lifeline between mother and baby, actually begins to form? It's a remarkable process, often hidden from view but absolutely crucial for a healthy pregnancy. Join us for a fascinating, science-backed journey into the very beginning of this incredible organ. Let's explore the hidden world inside early pregnancy together. Welcome to MedLifeLink. In today's episode, we're diving deep into the science behind the placenta, the vital organ that supports your baby's growth from the earliest moments. We're going to break down its formation stage by stage, using real research and medical facts to make this complex topic easy to understand. By the end, you'll have a new appreciation for this amazing temporary organ. So, what exactly is the placenta? In simple terms, it's an organ that connects the developing baby to the mother's uterus. Think of it as a super-efficient delivery service and waste disposal system all in one. It delivers essential nutrients and oxygen from the mother to the baby and carries away waste products like carbon dioxide. It also produces crucial hormones that maintain the pregnancy. But the real magic is in how this intricate structure begins to form from just a few cells. Let's get into it. Our story begins shortly after fertilization. The single-celled zygote rapidly divides, becoming a multi-celled structure. By about day 5, it has developed into what's called a blastocyst, a hollow ball of cells. This blastocyst has two main parts: an inner cell mass, which will become the baby, and an outer layer of cells called the trophoblast. These trophoblast cells are the real stars of our show today because they are the very beginning of the placenta. They are programmed with one critical mission: to establish a connection with the mother. The next major milestone is implantation, which usually happens around day 6 to 10 after fertilization. The blastocyst, now free in the uterus, needs to find a secure home to continue growing. The trophoblast cells on the outside of the blastocyst are incredibly specialized for this task. They begin to stick to and then invade the lining of the uterus, known as the endometrium. Thanks to pregnancy hormones like progesterone, the endometrium has become thick, soft, and rich in blood vessels and nutrients, creating the perfect welcoming environment. This step is what officially anchors the pregnancy and sets the stage for everything that follows. Once implantation begins, the trophoblast cells start to differentiate and get even more specialized. They split into two distinct layers. The inner layer is called the cytotrophoblast, which consists of individual cells that will continue to divide. The outer layer is the syncytiotrophoblast. This layer is truly unique. It's a large, multinucleated mass of cells that forms by the fusion of the cytotrophoblast cells. The syncytiotrophoblast is the invasive powerhouse. It doesn't just stick to the uterine wall, it actively burrows deeper, breaking down maternal tissues to tap into the rich blood supply. This forms the very first primitive connection between the mother's circulation and the developing embryo. As the syncytiotrophoblast continues its invasion, the cytotrophoblast cells behind it begin to organize into finger-like projections called primary chorionic villi. Think of these like the roots of a tree, branching out to find nourishment. Over the next few weeks, these villi become more complex. They develop a core of connective tissue, and eventually, tiny blood vessels form within them. These blood vessels are connected directly to the baby's own developing circulatory system. This is a critical step because it creates the interface where all the exchange happens. The mother's blood will pool around these villi, allowing oxygen and nutrients to diffuse across a thin cellular barrier into the baby's blood, and waste products to travel in the opposite direction. By the end of the first trimester, around week 12, the placenta has undergone incredible development. The connection between the maternal and fetal blood systems is now fully established and highly efficient. A key part of this process involves the placenta actively remodeling the mother's spiral arteries in the uterus. Specialized trophoblast cells invade these arteries, transforming them from narrow muscular vessels into wide, open channels. This ensures a steady, low-pressure, high-volume flow of nutrient-rich blood to the placenta, meeting the growing baby's increasing demands. This mature connection will support the baby for the rest of the pregnancy. So, why does all this intricate, microscopic detail matter so much? Because a healthy pregnancy depends entirely on a well-formed, properly functioning placenta. If any of these early formation steps are disrupted, it can lead to serious complications. For example, if the trophoblast cells don't invade the uterine arteries properly, it can result in poor blood flow to the baby, potentially causing fetal growth restriction. It's also linked to a dangerous condition called preeclampsia, which involves high blood pressure in the mother. Understanding this science isn't just academic. It's vital for developing strategies to prevent and treat these conditions, ensuring more healthy outcomes for both mother and baby. It's important to us that the information we share is accurate and reliable. Throughout this video, everything we've discussed is based on trusted scientific and medical sources. We draw from peer-reviewed studies published on platforms like the National Center for Biotechnology Information, NCBI, research from leading institutions like Cambridge University, and clinical guidelines from major obstetrics and gynecology organizations. Every step in this amazing process, from the blastocyst to the mature placenta, is backed by decades of real, rigorous research. We're committed to bringing you science you can trust. Did you find these facts about placental formation as amazing as we do? It's a truly mind-blowing process when you think about it. We'd love to hear your thoughts or any questions you might have, so please leave a comment down below. If you enjoyed learning with us and want more science explained simply, don't forget to hit that subscribe button and turn on notifications for Med Lifelink. Thanks for watching, and we'll see you in the next video.